A rational function has a slant asymptote if the degree in the numerator is exactly 1 greater than the degree in the denominator. So I have two examples here of how to find slant asymptotes. Let's check out this first example. Let's say we have x squared minus 3x divided by x minus 5. We can see that the degree in the numerator, or in other words, the highest exponent in the numerator, is a 2. While the highest exponent in the denominator, we can imagine this is an x to the 1. So the degree in the numerator is exactly 1 greater than the degree in the denominator. So we know that this rational function will have a slant asymptote. Now, to actually find that slant asymptote, we can use long division. So here's how we set that up. For the dividend, so the expression that goes inside of here, we'll write the numerator. So we'll say x squared minus 3x, and we'll divide that by the expression in the denominator. So x minus 5 goes out here. Now here's how we perform this long division. We're only going to focus on the very first term in each expression. So we're going to say, what do we need to multiply x by in order to get x squared? Well, that would be an x, because x times x is x squared. So what we can do is we can write an x up here, and I usually like to line it up wherever the x is in the dividend. And what we're going to say is, okay, let's do x times x, so that's x squared. And then we have to do x times negative 5. So that's negative 5x. So we'll write that right here. And now what we're going to do is subtract this expression right here. So we have x squared minus x squared, so that's nothing, so we don't need to write anything there. And here we have negative 3x minus a negative 5x. So that's the same as plus 5x. So negative 3x plus 5x, that leaves us with 2x. Okay, now we just have to keep repeating this process until the degree that we have right here is less than the degree of this expression. So again, we ask ourselves x, so we're just focused on this first term, x times what gets us 2x? Well, that would be 2. So right up here, we say plus 2. And again, we're going to repeat the process where we say 2 times x, so that's 2x, so we'll write that right here. And then we have to do 2 times negative 5, that's negative 10, so we'll write negative 10. So again, we're going to subtract this expression. So we get 2x minus 2x, that's nothing. And then if we want right here, we could say plus 0, just to have something to subtract. So 0 minus a negative 10, that's 0 plus 10. So we're just left with 10. Now notice the degree of this expression right here is now less than the degree of this expression. So that means we're done. So what that means is the 10 is actually the remainder. So we can write plus 10. And when we have a remainder, we just write it over the divisor. So x minus 5. So we're done with our long division, and the slant asymptote is simply going to be everything except the remainder. So right here, this x plus 2. So we can write our slant asymptote as y equals x plus 2. So that's our final answer. Now, the reason that we ignore the remainder is because when we're talking about asymptotes, we're talking about what's the behavior of a function as x goes towards infinity. So notice that when x goes towards infinity here, this whole expression is getting smaller and smaller and smaller, and it's approaching 0. So just ignore it when we say the slant asymptote is really just approaching this equation right here. All right, let's try one more example. Let's say we have this rational function, x cubed minus 4x squared plus 2x minus 5 divided by x squared plus 2. Well, we can see that the degree, or the highest exponent in the numerator is 3, and the highest exponent in the denominator is 2. So because the numerator is 1 greater than the denominator, that means we will have a slant asymptote. So to find that slant asymptote, again, we're going to use some long division. So we'll write the numerator here, and then we'll write the denominator on the outside. So x squared plus 2. So again, we're going to ask ourselves, x squared times what gets us x cubed? Well, that would be x. X squared times x is equal to x cubed. So I'll write an x up here, and again, I like to line it up wherever the x is in the dividend. So now we ask ourselves, x times x squared, what is that? That's x cubed. And then we do x times 2, that's 2x. So I'll line it up under the 2x. And then we're just subtracting this expression right here. So x cubed minus x cubed, that's nothing, that's 0. Now here we can imagine there's a 0x squared. So we can do negative 4x squared minus 0x squared, or minus nothing. That would still just leave us with negative 4x squared. And then we have 2x squared minus 2x squared, so that's nothing. And then we have negative 5 minus nothing as well. If we wanted to, we could have written a plus 0 right here. So we just bring down that negative 5. Okay, so the degree of this resulting expression is 2, and our divisor is 2, so we have to keep going. Remember, we keep going until this expression right here has an exponent that's less than the divisor. So we're going to ask ourselves, x squared times what gets us negative 4x squared? Well, that would be a negative 4. So we're going to write negative 4 up here in the quotient. And then we say, what is negative 4 times x squared? That's negative 4x squared. So we'll write that right here. And then we do negative 4 times a positive 2. That's negative 8. So we'll say minus 8. And then we will subtract this whole expression. So negative 4x squared plus 4x squared, that turns out to be nothing. Negative 5, this is going to be a plus 8, would be a positive 3. So because this now has a degree that is less than the divisor, that means we're done. So this 3 is just our remainder. So we can write plus 3, and remember we write that over top of the divisor. So x squared plus 2. So again, the slant asymptote is just going to be everything that we have up here in the quotient except the remainder. So it would just be y is equal to x minus 4. So that is our solution for this one. So you can use this same process of long division to find the slant asymptote for any rational function.